Hello everyone. This is a lesson summary of the lesson 11.5 double angle and half angle identities, which is a continuation from your previous trigonometric lessons that you learned in term 2. So in this lesson, our objective is to evaluate and simplify expressions by using double angle and half angle identities. So we'll be learning some more identities known as double angle and half angle identities in this lesson, and we will use those identities to evaluate and simplify expressions. We can use the sum identities that we learned in term 2 to derive the double angle identities. So for example, sine 2 theta can be written as sine of theta plus theta. Theta plus theta is 2 theta. So we can use the identity, the sum identity sine a plus b, sine of a plus b, but here a and b both are same, theta. So theta plus theta. The expansion was sine a plus b is sine a cosine b plus cosine a sine b. Since here both are a and b are theta, let me just mark it. So both a and b are theta here. So I can just write sine theta plus cosine theta sine theta. So they are the same thing. So I can write it as 2 sine theta cosine theta. So it's the same thing. Sine theta, there is sine theta here, cosine theta and cosine theta. So I can write it as 2 times sine theta cosine theta. This is how we derive the double angle identities. Similarly, we can derive the other identities for cosine 2 theta. So there are 3 forms for cosine 2 theta, and then there is 1 form for tan 2 theta. So these are the identities, and it's better if you can memorize these identities quickly. So sine 2 theta is 2 sine theta cosine theta. Cosine 2 theta is cosine square theta minus sine square theta, or 2 cosine square theta minus 1, or 1 minus 2 sine square theta. You can use any of the 3 identities as per your given, like whatever is given to you, you can use any of the 3 identities accordingly. Let's jump quickly into example 1, evaluating expressions with double angle identities. So the question is, find sine 2 theta and tan 2 theta if sine theta is equal to 2 over 5 and theta is between 0 and 90 degrees. Okay, so to find the value of sine 2 theta, we know the formula for sine 2 theta is 2 sine theta cosine theta. So I have sine theta with me, it's given, but the missing is this cosine theta. So I need to find cosine theta. Now, in order to find cosine theta, there are 2 methods you can use. You can choose a methods as per your easiness. Whichever you feel easy, you can choose the 2 methods. I will explain the 2 methods, so please listen carefully. The first method is by placing the values in the triangle. So sine theta means it is opposite over hypotenuse. So we can use this triangle. Okay, so opposite, this is your theta here, this angle is your theta. So opposite is 2 over hypotenuse is 5. So then you can use the Pythagorean theorem to get the value for the adjacent. So you know this, for the right triangle we have opposite side, adjacent side, and hypotenuse, and that's how we get the trigonometric ratios. So from here I can use these opposite, and also one thing you need to notice from here, there was a limit of your theta that was given. It was from 0 to 90 degrees. So that means it is in which quadrant? It's in quadrant 1. The angle from 0 to 90 means it is in quadrant 1. So you have to draw the triangle in the quadrant 1. Then use the Pythagorean theorem. X square plus y square equal r square. Okay, the Pythagorean theorem. So here our y was 2 and r was given as 5, and we can solve it. X is equal to, so they gave here in one single step. Let me explain. X square equal to, this 2 square will go to the other side, becomes 5 square minus 2 square. X is equal to square root of 5 square minus 2 square. Then you can solve it. 5 square is 25. So square root of 25 minus 4, which is square root 21. So that's how you get the adjacent side. Okay, now since I have the adjacent side, so I have the x value as square root, a second, the x value I found it as square root 21. So now I can use cosine theta is what? Cosine theta, as we know, is adjacent over hypotenuse, which is adjacent here is square root 21 over hypotenuse is 5. So that's your cosine theta value. Now, now I have all the things required to evaluate for sine 2 theta. I have sine theta, that's given. I just found cosine theta, which is this. You can just apply in the formula and evaluate the answer. So this is one method of solving for cosine theta. There is another method for solving for cosine theta, which is using the identity. The first identity I think you learned last term in trigonometry, sine square theta plus cosine square theta equal 1. So I need to find cosine theta. So keep this here. This one, keep it on this side and take the sine square theta to the other side. So it becomes cosine square theta equal 1 minus sine square theta, and therefore cosine theta is square root 1 minus sine square theta. So since I have the value for sine theta, I can just apply it here. It will be 1 minus, the value of sine theta was 2 over 5. So 2 over 5 the whole square, and then you can solve this in your calculator. To get the final answer, which is square root 21 over 5, as you got in the other method as well. So that means it's correct. Now you need to be careful about one thing, about the sign convention. When you are solving using this method, you should be careful about the sign convention. So since here the quadrant mentioned was, for theta, the quadrant was the first quadrant, so in the first quadrant all the trigonometric ratios are positive: sine, cosine, and tan. So it's simple because here I can just use positive. Let's say that if the theta was mentioned in some other quadrant, second, third, or fourth, then according to the sign convention that you learned in term 2, the ASTC, ASTC. So in the first quadrant, all are positive. Second quadrant, only sine is positive. Third quadrant, tan is positive. And fourth quadrant, cosine is positive. So as per that, you have to give the sign convention. So let me just... So cosine theta is square root 21 over 5. Then find the sine 2 theta, apply the identity, substitute the values for sine theta and cosine theta, okay, that we just found, and then evaluate it. You will get the answer as 4 root 21 over 5. The next part is finding for tan 2 theta. So I have the values of both sine and cosine. So I can easily find the value of tan. Tan theta is, we know that tan theta is sine theta over cosine theta. So using that, I can find, so tan theta is sine theta over cosine theta. So I can use that to find the value of sine theta was 2 over 3, was it? 2 over 5, I mean 2 over 5, and sorry, 2 over 5 over root 21 over 5. So 5 and 5 will cancel. The answer will be 2 over root 21. This is the value of my tan theta. And then I can just substitute so here they did rationalization, that's why they changed the 2 over root 21 to 2 root 21 over 21, rationalization of the denominator. Now once I have the value of tan theta, okay, I can just substitute it into the tan 2 theta formula, which is 2 tan theta divided by 1 minus tan square theta. Just substituting the value there and we'll get the answer. So 2, instead of tan theta, I can write 2 root 21 over 21 divided by 1 minus 2 root 21 over 21 the whole square, and that will give the final answer as 4 root 21 over 17. So the signs of x and y when you are plotting the triangle on the graph, so the sign of x and y depend on the quadrant for angle theta. So wherever your angle theta is, as per that you have to mark your x and y values. That's simple, you can understand. So here it's just given with sine and cosine, positive in which quadrants, negative in which quadrants, etc. Now, the same similar example. Just go through it quickly. They asked us to find tan 2 theta and cosine 2 theta. Cosine theta is given to me. So if cosine theta is given, for tan 2 theta, I need to find the value of tan theta. So tan theta, you can either find it using method 1 or method 2, up to you. If you want to find method 2, some people prefer using the formula instead of the triangle. So also you have to be careful about which quadrant it is. This is the fourth quadrant. Okay, so if I'm finding sine, so sine square theta, instead of sine square, I'll just write sine theta equal square root 1 minus cosine square theta. This is the same. There's a derivation from that, not derivation, I mean it is derived from the formula that is sine square theta plus cosine square theta equal 1. That's the formula. We use it and simplify to get only sine theta. So 1 minus cosine theta is given as 1 over 3. So 1 over 3 the whole square. And then we can simplify this. 1 minus 1 over 3 the whole square is 2 root 2 over 3. Okay. Now, since this is in the fourth quadrant, and we know that in the fourth quadrant sine is, the sine value is negative, so we have to put the sign convention properly. This will be a negative. So it is minus, actually the answer, let me just try to rewrite it again. So the answer is 2 root 2 over 3, but since it is in the fourth quadrant, we have to add a negative sign. Okay. This is if you are using the formula method. You can try the triangle method if you prefer that. It's up to you. So here they use the triangle method, and let's see what they found. So I found sine theta was 2 root 2 over 3. So I didn't, okay, let me just show you. We found the answer for sine theta as 2 root 2 over 3. So to find tan theta, I will be doing sine theta over cosine theta, which is 2 root 2 over 3 divided by 1 over 3. 3 cancel. It will be 2 root 2 over 1, which is 2 root 2. Since it is in the fourth quadrant, tan will be negative as well, because tan is negative in the fourth quadrant. Sorry. Okay. So it is minus 2 root 2. Okay. Minus 2 root 2 is our tan theta. So using the formula method. So even using the angle method, I mean the triangle method, you will get the same answer. Tan theta is, as you can see, it's written minus 2 root 2. Okay. So it's the same value. Then we can just apply in the formula of tan 2 theta, 2 tan equal 2 tan theta over 1 minus tan square theta to get the answer, which is 4 root 2 over 7. And same you can do for cosine 2 theta. Apply the formula. For cosine 2 theta, you already have the value of cosine theta. So just apply the formula and substitute the value of cosine theta in that, which was given 1 over 3. And you will get the final answer as minus 7 over 9. You can use double angle identities to prove trigonometric identities. So in the previous term also you did proving questions. So here the question is saying prove sine 2 theta equal 2 tan theta minus 2 tan theta sine square theta. So you should always choose a side and then start proving it and reach the end should be the same as the other side. Don't start solving both sides simultaneously. So I will choose this side because this side we already know. If I try to solve that we can, but this is easier. So 2 tan theta means I can write as 2 times sorry, 2 tan theta. You can take out this 2 tan theta common outside from both, and you can write 1 minus sine square theta. This common means you take out the GCF. So in both of these you have this 2 tan theta, and here also 2 tan theta you have. So if I take 2 tan theta out from here, it remains only 1 minus, if I take 2 tan theta out from here, sine square theta will remain, taking out the GCF basically. Okay, then start solving. 2 tan theta is 2 tan theta, just keep it as it is for now. 1 minus sine square theta is cosine square theta. We know that from the identity sine square theta plus cosine square theta equal 1. So using that we can say it is 1 minus sine square theta is cosine square theta. So now tan theta means sine theta over cosine theta. Then multiply with cosine square theta. 1 cosine with 1 cosine from here cancel. Cosine square means it is cosine theta into cosine theta. So one of the cosine you get cancel. It will remain as 2 sine theta cosine theta. Now what is this 2 sine theta cosine theta? We learned the double angle identities. It is sine 2 theta, which is the same as our other sine, or we can just say which is same as our LHS. This we started solving with RHS. LHS and RHS means RHS is right hand side, which is this side, right side. LHS is left hand side, which is the other side. So that's how you solve these questions. Now another example, let's take 2 minus sec square theta times 1 minus sine square theta. So again we'll start solving the RHS. So we can say we can write the 1 minus sine square theta again as cosine square theta. Okay, then we can open the bracket. Okay, open the bracket. That means, okay, this is a two-step process that I did here. So 2 multiply with cosine square and then sec square theta multiply with cosine square. So 2 multiply with cosine square theta is 2 cosine square theta minus, sorry, not sine, just sec. So here you'll write sec square theta multiply with cosine square theta. Now 2 cosine square theta minus, what is sec square theta? Is 1 by cosine. We know that sec is the reciprocal of cosine. So sec is 1 by cosine square theta and then into cosine square theta. So cosine square and cosine square cancel. What's remaining? 2 cosine square theta minus 1. Now what is this 2 cosine square theta minus 1? It's the double angle identity we just learned. 2 cosine square theta is the expansion for cosine 2 theta, which is the same as our left hand side. Okay, so this step they did not show you the expansion, so I just explained you how they got here. it was only 1. They wrote a 2 cosine square theta minus 1 directly without giving the expansion. So I just explained you that. Now, always choose to modify either the left side or the right side of an identity. Do not work on both sides at the same time. You can use double angle identities to derive half angle identities. So now moving on to half angle identities by substituting theta over 2 for theta. So the derivation process I will not be explaining much, but we'll directly jump into the identities. Sine theta over 2 is equal to plus or minus square root 1 minus cosine theta by 2. Cosine theta over 2 is plus or minus square root of 1 plus cosine theta by 2. And tan theta over 2 is plus or minus square root 1 minus cosine theta by 1 plus cosine theta. Now, you have to choose these plus or minus depending on the location of theta over 2. So wherever your theta over 2 angle is, depending on that, in which quadrant is your theta over 2, the first, second, third, or fourth, depending on that, you have to choose the sign convention, whether sine is positive in the quadrant or negative, or cosine is positive or negative, etc. You know that. Now, half-angle identities are useful in calculating exact values of trigonometric expressions. So, first question is use half-angle identities to find the exact value of cosine 15. So we know that 15 means 30 divided by 2. So cosine 15 basically means cosine 30 divided by 2. So 30 is our theta, okay, and theta by 2 is our 15, okay. So this is our theta by 2. So theta is how much? 30. So the angle is given as 15 degrees. So we know that theta by 2 is 15 degrees, means it is in the first quadrant. So that means the sign convention is going to be positive. Positive theta by 2 is positive. Let me just a second. Let me rewrite this. They just wrote positive in first quadrant. Positive is the location in this first quadrant, the location of the theta by 2, not theta. Don't confuse that again and again, I'm saying. So theta by 2 is in the first quadrant. We are in this case, even your theta is also in the first quadrant because it is 30 degrees. But when you are deciding the sign, whether it is positive or negative, be sure to analyze it according to theta by 2 and not according to theta. So the formula for cosine, okay, they did not mention the formula here one more time. So anyhow, let's write the formula on the side. Cosine theta by 2 is equal to plus or minus square root 1 plus cosine theta by 2. So as I said, here this is your theta by 2 and your theta was 30 degrees. Okay. So when you are substituting in the identity, you'll write cosine theta means cosine 30. Then evaluate that. Cosine 30, we know the value is root 3 over 2. I've learned from the unit circle. Now, after evaluation, you'll get the answer as root of 2 plus root 3 over 2. So this is your answer for cosine 15 degrees. Okay. Then you can check using your calculator. Input the value cosine 15 in your calculator and check if you get the same value as this one, the one you got here. Okay. So you will get that it's the same. Now, one more question. Solving when the angle is given in terms of radians. So if you want, you can solve this in terms of degrees by changing the angle from radians to degrees if you want, if you find it hard to solve in terms of radians, or if you know how to solve in terms of radians, then it's even better. So here the 7 pi over 8 is your theta by 2. So if I multiply it, so this thing is my theta by 2. So to get the theta, just multiply this with 2. So it will be 7 pi over 8 multiply with 2, which is 7 pi over 4. We know that. So 7 pi over 4 is in which quadrant? It is in the fourth quadrant. But we are not concerned about this one's sign convention right now. To evaluate the angle, I mean the tan theta over 2, since we are going to find tan theta over 2, we have to identify the location of this 7 pi over 8. Now 7 pi over 8 is in our second quadrant. Okay, 7 pi over 8 is in the second quadrant. How do I know that? You can just find the ratio of these two. Okay, so I think your teacher might have taught you a method for determining which quadrant it is, either from the unit circle or either just by finding the ratio where it is 7 by 8. That means it is less than 1. So it is in the it is more than 0.5 but less than 1. So it's in the second quadrant. So your theta by 2 is in the second quadrant, and tan is negative in the second quadrant. Tan is negative in the second quadrant. So you can write it like this. Okay, so as you can see here, the theta was 7 pi over 4. Okay, so the formula for tan theta over 2, they not write it here. Let's rewrite it again. Tan theta over 2. Sorry. Tan theta over 2 equal square root, plus we put a plus or minus here first, 1 minus cosine theta divided by 1 plus cosine theta. So theta, as we said, is 7 pi over 4, and I showed you how to find that. Okay, and since your theta over 2 is in second quadrant, it is negative. Okay. Also, cosine 7 pi over 4, the reference angle is pi over 4, and 7 pi over 4 is in the fourth quadrant, as I said, and cosine is positive in the fourth quadrant, so you can just apply the value. Pi over 4 is your reference angle, so 2 root, 1 by root, which is 2 root 2 over 2. Root 2 over 2, sorry. Root 2 over 2, 1 by root 2, or root 2 over 2, if you rationalize the denominator. So 1 minus root 2 over 2 divided by 1 plus root 2 over 2. And this negative sign is because your theta by 2 is in the second quadrant. So the answer that you will get is minus of root 3 minus 2 root 2. Okay, and then you can verify using your calculator if you're getting the same answer. Then comes, now when you're verifying in your calculator, make sure if you're using the angle in radians, make sure that you change the mode of the calculator to radians. If you do it in degrees, you'll not get the answer correctly. If you're doing it in radians, then you should change the mode to radians. If you're doing it in degrees, change the mode to degrees. Now, using the Pythagorean theorem with half-angle identities, they said find cosine theta over 2 tan theta over 2. If tan theta is given here and the limit of the theta is also given. It is from 0 to pi over 2, which is the first quadrant. So in all the half-angle identities, be it sine theta over 2, cosine theta over 2, or tan theta over 2, the trigonometric ratio we use is cosine theta. In all three of them, it is 1 minus cosine theta, or 1 plus cosine theta, or 1 minus cosine theta by 1 plus cosine. So it is cosine theta. I have tan theta, so I need to find cosine theta. So again, you can use the triangle method and then use Pythagorean theorem in that. So tan theta is given to you. Okay, so tan means opposite by adjacent. So opposite is the upper one, 7. Adjacent is the lower one, 24. And then I need to find the hypotenuse. I can use Pythagorean theorem to find the hypotenuse. So it is given in quadrant 1. So make sure the signs are placed correctly. So 7 by 24, you should make sure that the signs are placed correctly. It's for first quadrant, so it's going to be positive. So you can solve. Let's draw the triangle. So 24, and then there is 7, and this is your x. So x square is equal to 24 square plus 7 square. X is 25. So after that, if you got the value for cosine theta, you can easily, okay, they made the triangle on the next page. You can easily evaluate cosine theta over 2. The formula is 1 plus cosine theta, square root of 1 plus cosine theta over 2, the whole over 2. Now, it is positive because the cosine theta in the given question okay, so sorry, since our theta is in the first quadrant, half of it will also be in the first quadrant, obviously. So theta over 2 will also be in the first quadrant, and that's why we are choosing positive. Or you can actually choose based on your maximum angle, that is given pi over 2. Cosine pi over 2 is a positive. Now, square root 1 plus cosine theta, the whole divided by 2. Then evaluate by substituting the value we found for cosine theta, which was 24. We found the hypotenuse as 25, right? So cosine theta, we know that is adjacent by hypotenuse. So 24 by 25. That's how we got here. And then simplify it to get the final answer, which is 7 root 2 over 10. Lastly, evaluating for tan theta over 2, just apply, since we have the value for cosine theta, just apply the values, and the same condition applies here in the first quadrant. Tan is also in the first quadrant, everything is positive, so it's fine. So square root 1 minus 24 over 25 divided by 1 plus 24 over 25. Then simplify it to get the final answer, which is 1 over 7. And that's about the lesson. Thank you for listening.